Good morning, everybody. On behalf of the VDV project to this webinar. First of all, I hope all of you are doing well in these difficult times, of course. The initial idea was to have this event at a face-to-face workshop in the scope of the VDV Summit in Porto. But as you probably know, some of the programmed workshops have gone virtual, such as this one. So in these times of COVID-19, data change, especially health data, is key to monitor and control the pandemic. But at the same time, it poses challenges related to privacy, security, and several ethical dilemmas. Today, precisely, we have the pleasure of having several speakers that are going to present their work around health data access and sharing and provide us with a view of the challenges, potential approaches, and recommendations. But before I give the floor to our speakers, allow me to say a few words about the logistics of the webinar. So some housekeeping rules before jumping into the webinar. Please, if you are interested in topics related to big data and analytics, I suggest you to go regularly to our webinar webpage that I showed at the bottom of the slide. In this URL, you will find more information about the past and future webinars, as well as links to all the previous recording and slides. This recording of this session and the slides will be also made available through this link. You don't have to write down the link because the system will send tomorrow one message, one email to all of you with the link to these slides and recording. As you know, due to COVID-19, we are relying on Wi-Fi connection. So that means that there is a small chance that the connection could fail during the webinar on our end. If this happens, we will resume the connection as soon as possible. So please, if this unluckily happened, try to reconnect in a few minutes. It's just a suggestion in case something wrong happens. So if you want to ask any question to the audience or to the speakers, please write the questions in the question chat that you have in the controls. At the end of the session, the speakers will answer your questions. Right after the end of the webinar, you will be directed to a brief survey to get your feedback and recommendation about the webinar. But now I'm going to ask you a couple of questions in the form of a poll related to the particular webinar. So let me send you the first question about the webinar, and it's about your organization. So I'm launching the questions as we speak. So the first question is about your profile, and let us know if you have an academic profile or you come from an industrial organization or from some other. So I note that you are voting so far, so I give you a few more seconds to finalize the poll. Okay, a few more. Okay, I closing this poll now. And apparently it's around 34% of the people are from the academia, 50% are from the industry, and 18% are from other type of organizations. So this is a feedback also for our speakers today. And the second and last question is more related to this particular webinar, and is the interest that you have in using or sharing health data. So I'm starting the poll now. So the first answer is about if you are interested in sharing data, health data, or if you are interested, is the second answer, in using for creating some specific applications, health data. And the third question is about if you are just interested. It's an answer. The third answer is about that you are interested. If you are just interested in the topic. Again, I give you a few more seconds. Okay, I'm closing now the poll. So the answer is that 17% are interested in sharing data, 44% in consuming data, health data, and 39% are interested only, but not actively using or sharing data. I think this is interesting also for our speakers to know the type of audience that we have. Okay, so without further delay, let me hand over to Alexandra Muñoz from Incliva, Valencia in Spain, who is going to moderate this session and introduce our speaker today. So, Alexandra, I'm giving you right now presenter's right. 1 second. And now the floor is yours. Thank you very much, everybody. Alexandra, you're on mute. You should unmute yourself.
Oh, yes, now, thank you.
Now it's fine.
Hello, well, let me introduce myself. I'm Alexandra Muñoz, and I'm a science communicator at Incliva Biomedical Research Institute in Spain. I would like to present the speakers of this webinar. Dr. Ricard Martínez, he's a lecturer of constitutional law at Universitat de Valencia. Dr. Javier Gámez, he's a project manager at Incliva and partner on the BigMedilytics project. Alex Sengers, he's a technical consultant at TNO and partner on the BigMedilytics project too. Dr. Juan Vicente Durá, he's a researcher at Instituto de Biomecánica de Valencia and the BodyPass coordinator. And Dr. Jonander Gómez, he's an associate professor at Universitat Politécnica de Valencia and partner on DeepHealth project. And the agenda of the webinar is as follows. First, Dr. Ricard Martínez will give an overview on the challenges of secure access and exchange of data in the health sector. Then, we will know how these 3 EU-funded projects are facing the challenges. Dr. Javier Gámez will present the comorbidities pilot within the BigMedilytics project. Alex Sengers will talk about the heart failure pilot within the BigMedilytics project. Dr. Juan Vicente Durá will present the BodyPass project. Dr. Jonander will talk about the DeepHealth project. Finally, we will have the discussion and questions and answers from the audience, and we expect this part to be quite interactive. Why are we organizing this webinar? The health sector is facing a paramount challenge, especially important during this pandemic. How to exchange and grant access to health data in a secure way, enforcing the current national and European regulations. In this complex challenge, converge 2 different interests. On one hand, we have to respect the individual rights and interests of the patients and citizens, and on the other hand, the scientific community should promote the research in pursuit of the public interest. To face this challenge, we can find different approaches across Europe, and in this webinar, we will present 4 examples of how 3 EU-funded projects are tackling it. And Ricard Martínez, the floor is yours.
Okay, many thanks. I think I'm sharing my presentation, isn't it?
Yes.
Okay, wonderful. Good morning to everybody. I hope you will be safe. There are very, very difficult moments for us. And I'm really grateful to share our findings in different projects on health research regarding data protection, privacy, security, and so on. I try to explain to you my approach in 10-15 minutes, but not only putting my focus on our previous experience in BigMedilytics and BodyPass and in other projects, but in the positions of the European Data Protection Board, because they provide us a lot of statements, guidelines, and so on regarding processing data in the context of coronavirus fighting. What regards to health research, really could explain really with a few words. There are no news, except in data transfers, probably, and in the use of vital interest of legitimation basis to process data. The EDPB say us that, okay, scientific research is a research project set up in accordance with relevant sector-related methodological and ethical standards in conformity with good practice. Okay, this is what we are doing now. This is not news. Of course, I think the most interesting question for us in the future will be the context of obtaining consent in the primary use cases, but probably the most relevant questions will regard the secondary use of data, because we are generating amounts and amounts and amounts of terabytes of data regarding coronavirus patients that will be used in future. From the EDPB, we have to remember the concept of data concerning health, but I think the most interesting thing to be considered is the reference or the health data considering the reference or by context. Because, of course, we are not talking only about the data in a health record, but it's really interesting the cross-reference with other data. For example, not only regarding health, but health risks, or data regarding socioeconomic data, residence in neighborhoods, or geolocation. From the EDPB perspective, there is no ranking between the legitimation basis stipulated in the GDPR. Then, of course, we could use consent as legal basis, but we have to consider national laws. For example, in Spain, we don't need a national law to obtain consent for research, but in other countries, it is a requirement. In case of using the consent, we have to be sure that this must be freely given a specific informant and so on. And this is really difficult nowadays, because EDPB remember us that the consent must be freely, and freely given only will be possible if there is a clear imbalance between the data subject and the controller. We are talking about patients with a disease, with a really serious disease. It's very difficult to obtain consent directly from this kind of patients. Then they must be in a situation without dependency. Then I think that consent don't be a very good idea. In any case, there are additional requirements. We have to make this in a clearly distinguishable from other matters and so on, and there must the right to withdrawal. National legislation provides additional safeguards. This is really important because we need legal predetermination, the definition of purposes, and additional safeguards. I think that the Spanish case law is a really interesting approach to that, because we could process data, health data, for research with consent, and I think this law needs additional explanations, but we have specific provisions for public health. In that days, in case of epidemics, health authorities and public institutions with competence in public health surveillance may carry out scientific studies without the consent of the affected persons in situations of exceptional public health relevance and seriousness. This is really interesting because in our case, health authorities, public institutions could process data from health records directly, identifying persons and without consent. I think this is a very interesting provision. In any case, we could use consent or use pseudonymized data. In this case, our law requires us an express confidentiality and commitment of no and non-re-identification agreement from researchers, and to adopt security measures. We have to prevent the re-identification and access non-authorized from third parties. Additionally, we have to implement a data protection impact assessment, and we need the approval of the Research Ethics Committee. I don't talk about transparency and other really well-known principles, because I think it's most interesting to talk about the international data transfers. In that case, EDPB opened the possibility to share data with other countries, with third nations, invoking the public interest, but it needs an urgent actions in the field of scientific research. And they give us an example. For example, to develop vaccines. But I think that the problems or the discussion, the public discussion about geolocation data is really, really relevant to a big data approach to COVID. The reason is that everybody is talking now about the location data as a really, really interesting tool to research on coronavirus, not only considering health, but considering mobility of people and relations between socioeconomic data, pandemic situation, prevalence, and so on. Then the EDPB states, the presidency of EDPB clearly states on March that we have to fulfill the law. But the law in that case is not only the GDPR. We have to apply the e-privacy directive. This is a law from 2002. It's a really old law. It means that we have to apply a law to be used in telecommunications, not in health research. Then, from the point of the e-privacy directive, the data can only be transmitted to authorities or other third parties if they have anonymized by the provider or with the prior consent of the users. And in terms of location data, we need this consent, or we are law enforcement bodies or judges, of course. In that case, the derogations in the law, in the directive, don't consider health, research, or public health. Then we have to go to national laws to identify a legitimation basis to use location data in health, and it doesn't exist, usually in any country. Then, at the end of the day, we have to anonymize this data. And from the point of view of the EDPB, of the DPAs, the data protection authorities, anonymization implies a very strong effort. I copy you directly the opinion of the EDPB. If you see paragraph by paragraph, you will see that in paragraph 20, they said, okay, this is really difficult. In practice, there are researches that show that it's really difficult. It's practically impossible. If you see paragraph 21, they say that it's really difficult to fully anonymize a tracing of the location of an individual, and in any paragraph. From an emotional point of view, I feel every time I'm reading an appointment and an opinion of the DPB, that they really consider that anonymization is really impossible. I'm not agree with that, but this is our reality. We have to adopt special safeguards if we process location data or anonymized location data. This is the reason that we have make a solution built in different pillars in BigMedilytics. For example, we have to be sure that the data have a legitimate origin. And that's it means that we have a contract, an administrative resolution, and so on from the health authorities. We adopt a strategy of risk analysis. We don't feel comfortable with the data set till we have analyzed the anonymization of that. And if we have implemented 2 layers, 2 steps of anonymization, we adopt security measures, some as those applied to personal data. It doesn't mean if there are no personal data. For us, it's the same. And we have implemented processes to ensure a controlled access without the possibility of data extractions. I think that Javier will explain you it deeply. And at the end of the day, we implement legal guarantees from or between partners. We call that data sharing agreements to provide security and certainty in legal terms. To conclude, in my opinion, the DPAs are really worried in privacy matters. Sometimes I think that they don't consider human beings as a whole. I think we need a real practical approach to implement processes of research with health data, with massive health data, with security and certainty. Of course, we are really worried about the rights of the patients. We are really involved with privacy and security, of course, but the statements and the approaches of DPAs can be a certain definition of obstacles and obstacles and obstacles. We need to align the interests of health and research with data protection of patients. And from that point of view, we need a new kind of approach of DPAs working with us to use the data from or for common goods. Many things. I think that I give the floor to my colleague, Javier. Let me try to do it. Have you that, Javier?
Yeah, I'm on my way. Can you see my screen? Can you see my screen, right?
Yes.
Okay. Okay, thank you, Ricard, and thank you, Tomás and Alexandra, for your presentation and the invitation, and that I have to be part of this webinar and share with you what are we doing in one pilot of the BigMedilytics project. So my name is, as you can see in the screen, Javier Gámez. I am project manager at Incliva. Incliva is a biomedical research center. We are based in Valencia, and we are managing the research of the clinic hospital. We are working very tightly with the regional Ministry of Health. So that means that we are working with the data of the population of the Valencia region. So that means more or less 5 million people. So we have the privilege and also the responsibility to work with this huge asset of data. And our basic principle is I would say, is the opposite of the Gollum principle. So because we are very happy to share our data with a concrete aim. Let me check. So I'm going to present you very briefly BigMedilytics. BigMedilytics is a funded project by the European Commission. 35 partners from 12 countries are involved. As you can see in the screen, the main actors in the healthcare sectors are involved in this project. And we are treating more or less 11 million patient health records in total. The main aim of BigMedilytics is try to transform the healthcare sector using big data technologies to try to achieve a breakthrough productivity by reducing the cost, to improve the quality of the health services and also fostering its access. Our main framework is the healthcare continuum that consists of these 4 stages: prevention, diagnosis, treatment, and home care. So BigMedilytics is structured in 12 pilots that cover 3 themes. The first theme is population health and chronic diseases. Here we are working in 5 pilots. The second theme is oncology. In that case, we rely on 3 pilots, as you can see here. And the third theme it is called industrialization of healthcare services. In that case, we have 4 pilots. So today we are going to talk about how we share data and how we grant access to the data in 2 pilots: comorbidities, that I will present, and my colleague Alex will present the heart failure pilot. So regarding the comorbidities pilot, as an introduction, let me tell you that multimorbidity and comorbidity is one of the main challenges in the healthcare sector. Its prevalence is increasing across Europe day by day. So the main aim of our pilot is try to develop a decision support system for GPs, for physicians, based on exotification and clustering of the population in order to assess the hospitalization risk and mortality. So this pilot has been structured in 3 steps. So as you can see in the screen, the first step is the retrospective analysis. So here the idea is to analyze the data of the of the Valencian community. So it's more or less 4 million people, and we are doing that in collaboration with other partners apart from Incliva. So here, this is the point. Here we need to share data to grant access to data. So this is the main objective of our pilot. And in my presentation, I structure in 2, or the content is based in 2 main parts. The first part is approaches, which are our approaches. So I divide this approach in 3 pillars. The first pillar is anonymization, the second pillar is technology, and the third pillar is the legal aspect that Ricard already explained in detail. So I will focus on data anonymization and technology. Regarding data anonymization, this is the process that we follow. This is one of the main steps that we conduct in order to treat data. So first, we receive the data, as you can see here in the screen, from the regional Ministry of Health. This data is already codified or pseudo-anonymized, and we start the process. So the first step is we remove all variables, all data that we don't want to analyze. So we don't need to analyze, we don't need to include this data in our research. So first step, we remove data. Second step, we disturb data, and if we need it, we can encrypt some variables. After that, we conduct the risk assessment. We have to be sure that the risk assessment that we have, the re-identification risk that we have, is very low, as Ricard was pointing out in his talk. So if we are not happy with this risk level, we start over the process. And if we are happy with the final outcome, then we can start the research. Regarding technology, the technology approach that we follow, I would like to introduce a concept that I learned in one ICT Proposals Day that the Commission organized. This is the concept called visiting concept. The concept is very easy to understand. Let me give you some hints. So here you can see our colleague from could be industry, universities, any organization. She is in her premises, and from there the data from Incliva is in another, of course, it's in Valencia, in our cluster, in our computational cluster. So what we provide to our colleagues is a channel to connect from the premises to our data. One important thing is that the data never leave our premises. The data is always with us, but we grant access to our data. As I said in the beginning, we are very happy to share our data. So in the next slide, I try to show the steps that we follow to make these things happen. This is the cluster of Incliva, as you can see here. I hope that you can see my mouse. This is the structure that we have at Incliva. And here, as you can see, we have the partners that we are working in pilot number, in the comorbidities pilot in BigMedilytics. So it's ITI, Philips, and Optimeris. So the first step is that we cut the connection between the nodes of the cluster and the database. Second step is that we allow our partners to install and upload to the repo their tools, algorithms, whatever they want to test. Next step is that we put all these tools in the front end. This third step is made by us, by Incliva. So once we have all these tools installed and set and prepared to be used, the partners using a remote desktop can have access to internet and set everything. They can set up all the technology, algorithms, tools, whatever. After that, our partners say, okay, I finished the setting up. So we cut the access to internet and we open the access to the database. So in that position, in that step, our partners can work in the data. So once they finished and they have some results, some metadata or outcomes, then we put this data in the repo. But one important thing, this step number 8 is a manual audit from the people of from my colleagues of Incliva. So the main aim here is try to be sure that the data or the final outcome that the partner is taking out doesn't include any personal data. So once we audit this information, we allow the partners to take out their final outcomes and results. So this is very briefly all the steps that we follow to make things happen, to make this visiting concept happen. Regarding the recommendations that we, in a humble way, share with you, I have divided in these 3 pillars. So the first pillar, the technology pillar, our recommendation, we recommend you to have a server in your premises if possible. We recommend you to use a VPN connection with 2 steps authentication. Also, the traceability is very important. We have 1 login per person to track all the access. It's also very important to have a virtual environment implemented, a redundant server. So everything is double. At least we have 2 copies of everything, at least 2. Because we know some partners that have till 8 copies. And regarding the requirements, we propose you to have this fast access and slow access, 1 terabyte of RAM, 10 gigas of Ethernet, and 24 cores. Regarding the anonymization, we recommend you to have this double anonymization process, as Ricard was mentioned before, to conduct a real identification risk assessment. This is very important, and check the recommendation of your national authority. Because in our case in Spain, the DPA, the Data Protection Agency, provide some guidelines to conduct anonymization. So that helped us a lot. And finally, in the legal part, we recommend you to sign a bilateral agreement among partners. And also you have to bear in mind we're very well known nowadays in the GDPR context, the accountable or accountability principle. So you have to be able to document everything and show that you comply with all regulations. Lastly, you have here like 3 sentences that could be applied to all of the pillars, so technology, anonymization, and legal. So let me read one by one. So the first one is act as if fully anonymized data doesn't exist. Reach the highest levels of security as possible. And prove that you apply all possible measures. So thank you very much, and I'm looking forward to the discussion. Let me sorry. Okay, let me change the presenter. Let me give the floor to my colleague Alex, that he will present the other pilot of BigMedilytics. Alex, the floor is yours.
Yeah, thank you. But I think John at this moment has the control. Yeah.
Can you?
Yeah.
Take it from here. Okay.
Yeah. Can you see my screen?
Yeah.
Right. Great. So thank you, Javier, for the introduction and also for the introduction of BigMedilytics. So as Javier was already mentioning, my name is Alex. I work at TNO, which is a Dutch research institute. We are also involved in BigMedilytics in another pilot, which is about predicting heart failures using multi-party computation. And it's a pilot with a hospital, Erasmus MC, and a insurer company, Achmea, and TNO. So the question in our heart failure pilot is to identify whether heart failure patients require additional care. So you have to imagine that a heart failure patient arrives at the hospital and the doctor measures and requests all kinds of information about this patient. And the doctor then needs to assess and use a prediction model to see whether this patient required additional healthcare interventions and is a high risk patient. But the challenge with these kind of approaches is that this for accurate predictions you need actually quite some patient data in order to train this prediction model. For this specific patient that is arriving, you might get consent in order to help him with this treatment. But in order to use this prediction model, it has to be trained with maybe some machine learning model. And getting this consent of this large group of patients is very challenging and also time consuming. So yeah, that's why it would be great if we have a solution for that. And what we are doing in this pilot is we are combining the data from the hospital with the data from the health insurance company. And what we are doing actually in an experiment at the start we start with fake generated data. Is that on the one hand we have the hospital which has is following, let's say, some people in a specific neighborhood for years and years. It's a study, and in this study they know something about smoking behavior of those people, alcohol behavior, exercising, things like that. And on the other hand, we have claim data from the insurance company with respect to heart failure, but also respect to other diseases. And we would like to combine these features you have to imagine that this is, there are maybe partially the same persons in these data sets, but this is different kind of data. It would be very useful to combine this data to get a richer, richer prediction model and a more accurate prediction model. But on the other hand, of course, this is, if you would like to do this, this is very challenging because there are a lot of reasons not to share this data due to, for example, privacy concerns. GDPR is of course mentioned, but also in other processes you might imagine that sometimes this data has value and has business value even. They don't want to share this easily. So this is our data sharing challenge. How can we identify heart failure patients with a high risk of early hospitalization or mortality? Well, the challenge here is to build this prediction model, and how to couple this hospital and insurance data is not easy. And the approach that we are following is, well, we start with an observation. That is, at the end, we don't want to actually have this data. We just want a model to be able to predict. We don't need necessarily the data. So there's a sort of a paradox. On the one hand, you have data sharing and cooperation, and it seems to be that you cannot have this with privacy and confidentiality. But this is not true, because in this example you see, for example, well, a very small exercise or small example with on the horizontal axis you see the exercising, which is what might be one feature that the hospital has on this on some people. And on the other hand, you can see hospitalization days, which is another feature, but that's data from another party. And you see all these blue dots, and that are all patients, but this is sensitive data. You cannot share this data because this is personal data. But at the end, we are not interested in all these blue dots. We're just interested in a resulting prediction model, which is in this case, in a very easy example, you can see that there's a relationship to how much do you exercise in a week and the number of hospitalization days due to heart failure. And we are, for the prediction model, just interested in this red line and not on the sensitive blue dots, which is personal data. So what we're using in this is multi-party computation, which is basically a cryptographic protocol in order to cooperatively compute or perform a computation. So, and the idea is that you do not share any sensitive information, not any sensitive data, but only receive the outcome of the computation. So we have to imagine, for example, that there are 4 parties here that are willing to, let's say, for example, compute their average salary, but they do not want to reveal anything about their salary on an individual level to each other. So the idea is that they do not use a first and third party that performs this computation for them, but they are using multi-party computation in order to use all kinds of cryptographic techniques to compute this average salary. Well, and this is a technique that can also be used, extended to all kinds of other applications. And multi-party computation is already existing for let's say 25 years or 30 years. It's not a one-size-fits-all solution. So you have all kinds of different cryptographic techniques. And you have to design really a solution with a trade-off between what do you want to compute, how complex is the computation, because that requires more computation time, maybe another solution as well. And there's also a question to what extent you find security very important. And during the last couple of years, there's have been shown really improved practical applicability, and also all kinds of software libraries that you can use in order to make it more easy to implement multi-party computation solutions, as we did for BigMedilytics. So if we go to our, let's say, architecture of this solution that we implemented within BigMedilytics, that we are currently working on let's say, an experiment at this moment using generated data, fake data on the parts of Erasmus MC and Achmea. We are currently implementing 3 servers. We are installing the MPC software, the multi-party computation software, at these different different parties. We encrypt all the data. So we have to imagine that the data that is shared among the parties is all encrypted and cannot be decrypted by either of these parties, but they have to cooperatively compute on this data in order to get the outcome. And that's the only thing that they can. So they will never get any insight in the data of another party. And in this way, this is a solution in order to train a prediction model of multiple organizations that can involve, well, thousands of patients potentially, but without revealing anything else than just the prediction model at the end. That's all from my part, actually. So thank you all. I'm gonna make Juan the presenter now.
Okay.
So Juan, there you go.
Yes, let's go. Okay. I think you see my presentation now.
Yes,
we see it.
Okay, then, well, my name is Juan Dura. I work in the Institute of Biomechanics in Spain, in the city of Valencia, and I am the project coordinator of the BodyPass project. The BodyPass project is focused in a specific, a specific type of data that is the three-dimensional data. I will explain later on what it means. Let me present.
Juan, you're muted.
Let me present the consortium. The consortium is, in the consortium, we have 3 technological partners that provide the algorithms and all the software, the tools that are Institute of Biomechanics, Atos, and Philips. And we have 2 partners that provide data, and they use data from the healthcare sector. We have Incliva, with the data from the hospital in Valencia, also the Instituto Auciologico from Italy. They also manage data from the hospitals. And we have other two partners that represent that companies that use three-dimensional data for manufacture or sell garments and other consumer goods products. Why we mix partners from 2 different sectors? Because the BodyPass project was presented to a specific call that the objective of the call was to break barriers between sectors, to share data between different sectors. In this case, we have one sector that is the healthcare sector and the other one that is the consumer goods sector. Then, first, what is personal data? In the case of garments or consumer goods sector, usually the personal data is the standard body form. They use some, at the moment there are technology to measure the body form of the people. In the case of the medical sector, the healthcare sector is maybe more complicated because we have the standard body parts and also the internal body parts. Then, why to share data? Okay, the idea of the project is that we have 2 silos of data. We have people that have three-dimensional data from healthcare sector and consumer goods sector. The idea of behind the project is that the three-dimensional data at this moment that are now in the hospitals could be useful not only for the internal body information, also for the designers and manufacturers of other products, and also the external body forms that many people are measuring shops, etc. could be used also for in order to do clinical applications, large scale epidemiological surveys, etc. Then, why this is big data? Well, in the case of in the hospitals, it's very clear. At this moment, there is some estimations that they collect about more or less 2 to 7 petabytes every year. In Europe, in the case of consumer goods, the consumer goods sector, now there are some estimations that more or less every 50 minutes, one person is scanned in order to measure the body form, and this is increasing because at this moment we already have technology that you can have your, let's say, your own scanner in your phone, and you can obtain your body form. Then our objectives in the project is to generate tools for extracting the three-dimensional model from the raw data of the scans, and they generate protocols that we are able, in order to be able to exchange this data in a secure way. In BodyPass, we are first, the problem we have with this specific type of data is that this data, first we had to curate the data because the scans that we obtain, the raw data is not good. We had to first to eliminate noises, to process the data, just in order to curate the data and obtain the body form without noise, without holes, etc. The second problem that we have in the project is that we have to solve interoperability problems because this type of data could have different resolution, different formats, etc. And we have when we are talking about three-dimensional data, the big problem is that the three-dimensional data is not just numbers, it's not a table of data that we can agree what is the name, we can agree in a table, we can agree in the headlines of the columns, we have the name of the variable, we can agree, and we can apply directly some calculations, average, etc. But in the case of three-dimensional data, we have the problem of that if we want to apply directly some calculation, is not possible because just imagine that, just an example, imagine that we had two databases of body forms in different postures. If we want to make a simple average, we will have an error because you see in this example that what happened with the arms. Then first we had to create pros algorithms that put all the three-dimensional models in the same position and fit in order to be able to make the different calculations. Then the solution that we are using is to use what we call a standard templates. A standard template is an agreement between all the data providers in order to use the same avatar that represent with the same number of points, with the same position of the point in the mesh, etc. In this way, it's possible also to define body parts, and the main advantage is that when we use the same template, all the points in the avatars, in the three-dimensional models, have point-to-point correspondence. Then it's easy to apply all the algorithms that will aggregate data, calculate percentiles, make regressions, etc. Then what we are doing when we when we have implemented in our in the technology that we are developing is algorithms that use the standard templates in order to adapt all the body forms from different databases to put all the three-dimensional models in the same position before to make any calculation. Then with the standard template, we are able to define very easy landmarks and obtain metrics for the different body forms and compare the metrics from different people. At this moment, we have already a data catalog implemented in our architecture with a definition of a 77 metrics, different 70 metrics that could be used by the healthcare sectors and the consumer goods sector. But also the importance, the most important that we don't only have the metrics, we are able to share, to exchange the 3D data. Then anybody can define their own measurements and to use different algorithms, different approaches. One point that one of the problems, of course, in this case is the anonymization problem. What we are using in order to anonymize our three-dimensional data is the concept of synthetic data. In the synthetic data is a data, you know, that represents the original data, but it's not the original data. It's something that is in this way we are able to share anonymous data. The idea in the project is that from the raw data we eliminate any characteristic, anything that could identify the people, and we create synthetic faces, synthetic body forms, etc. In our how we share the data, okay. The architecture that we are defining is based on a blockchain network. Okay, in the middle of the architecture is a blockchain network, and then we have the people, the data providers, the people with the partners that have the databases with the three-dimensional data, and we have developed several APIs that any client could use to connect. Any client could use, they connect with the API to the blockchain network in order to define the different queries. The blockchain network is used to register all the transactions, and the blockchain network connects to the off-chain components that are developed and provided for every partner that provides data, and send the results of the query. The objective to use blockchain networks is to provide trust to the different partners that participate in the network, and to have a register that is very difficult to hack or to falsify. Okay. Then,
Juan, sorry, we are passing the allocated time.
Okay, I'm finishing one moment. Then, with this possibility, we have defined the different queries. You see, it's possible to get one individual data, and also to get many anonymous individual data. But each data provider chooses which queries is possible to answer and to in the databases. What happened at this moment? At this moment, what happened is that in the case of the hospitals, at this moment, they agree only to answer to queries that ask for aggregated three-dimensional data. Why? Because they are very cautious. Even that we have developed different algorithms in order to create synthetic data and anonymous data, the GDPR is a gray area at this moment. In the GDPR, you have to demonstrate that your data is really anonymous. How to do that? That's the problem. It's not clear how to do that, how to demonstrate what is anonymous data. And for this reason, one of the projects that we have at this moment that the hospitals only they only provide access to aggregating data. Then, as I think that I should finish here because we don't have more time. I will look forward to your questions, and I will provide the next the floor to John. Okay. I will give control. To John. John, the floor is yours.
Okay, thank you. Good morning, everybody. Could you see my screen?
Yes, we can see it.
Yep.
Okay, thank you. Well, first of all, I will thank you, the organizers of this virtual workshop, mainly the people from the BigMedilytics project and also the BDBA. So thank you for inviting us for participating. Well, let me to dedicate a few minutes in order to do a quick presentation of which is the DeepHealth project. I have to say that I am the technical manager of the project. It was presented before by Alexandra, so it's not necessary to add anything else regarding me. Well, first of all, I would like to highlight the goals of this project. First goal is to put HPC computing power at the service of biomedical applications with deep learning needs and apply deep learning techniques on large and complex image biomedical data sets to support new and more efficient ways of diagnosis, monitoring, and treatment of disease. Well, one thing I want to highlight thanks to this first goal is that this project is in the health sector. I mean, is using use cases from the health sector, but this is a project that belongs to a call which is related to HPC and big data. So our main goals is to develop software tools in order to exploit HPC and cloud infrastructures, okay? Also, another of the important goals of this project is to facilitate the daily work and increase the productivity of medical personnel and IT professionals working in the health sector in terms of image processing and the use and training of predictive models without the need of combining numerous tools, because sometimes people, I mean, computer scientists working on the health sector need to use too many tools developed by different developers or different companies, and making all together in order to complete a pipeline in order to do all the transformation to images and training the models they need is not an easy task. So our idea is to offer a unified framework adapted to exploit underlying heterogeneous HPC and cloud architectures, supporting state-of-the-art and next-generation deep learning and computer vision algorithms to enhance European-based medical software platforms with the purpose that we want to facilitate the daily work of computer scientists, as I said before, but without that these people, I mean, these computer scientists, they don't need to have a deep knowledge about deep learning, about how to manage or how to train the deep neural networks. They have to know the domain application, in this case, in the health sector, the different tasks and purposes related to different diseases, and then to use this tool in order to train the models, but not to develop and not to write the code for such. Okay, so the unified framework will be like a toolkit in order to facilitate the work of these people. Okay, well, in order to summarize the key facts of the project, it's a 3 months project, okay, that is going to be carried out by, is being carried out by 22 partners from 9 countries, okay. Well, the expected results of this project, as I told you before, is the DeepHealth Toolkit, which is composed by two libraries, the European Distributed Deep Learning Library and the European Computer Vision Library, that together with a web-based graphical user interface will complete the DeepHealth Toolkit, okay? The idea is that this toolkit will allow, as I told you before, in a transparent way to computer scientists working in the health sector, they can use the underlying HPC infrastructure in an efficient way in order to train models and also even for inferencing, okay? Well, this project will be validated thanks to 14 use cases belonging to different topics, neurological disease, tumor detection and early cancer prediction, digital pathology, and automated image annotation. And these 14 use cases will be tested in pilots using 7 platform or software platforms provided by some of the partners of the project, okay? Well, the concept of the project can be summarized in this slide. On the left-hand side, we have the production environment when mainly they operate the doctors and the medical personnel in general. And for these people, I mean, for the medical personnel, they work with the software platforms will be transparent as they usually do. They have new inputs, I mean, new images, and they can use a software platform that can provide some feedback, some prediction, some score, okay, some cues about the samples in order that these cues, this information, in fact, can help them to make decisions during the diagnosis process. The unique a little effort we ask them in this production environment is that they have to label and annotate images in order to help us to have more quality data, okay? So they use the software platforms from the user point of view. They don't know anything about any of the process for training models or for managing and processing images, etc. But on the right-hand side of the slide, we can see where the DeepHealth Toolkit operates. So the ICT expert, I mean the computer scientist working in the health sector, validate the images provided by doctors as new images are acquired day by day. Then they are growing the biomedical data set day by day. And with new data, the same models or maybe new models are trained. And the ICT expert changes or updates the model in the software platform in order to improve, because this is a never-ending process of improvement, to improve the robustness and the quality of the models used by doctors, okay? This is the purpose of the project, okay? Well, I will skip these 2 slides related to the current status of the project, and then I am going to focus your attention in the challenges and difficulties identified in our project. Okay, the first one is data sharing among project partners, which is not always possible, and also data is not curated enough. Before going to the other slides, I would like to highlight that the problems and the suggestions provided by my previous colleague, the previous presentation from Dr. Gomez, from Alex, from TNO, and also from Juan Vicente, are interesting. They raise different questions which are very important. Even some of the techniques about encryption, data encryption, and so on, we are also using that. I didn't highlight this in the slides because I think when we transfer data, it should be properly, not only properly anonymized, but also encrypted. So in addition to what they comment, we have facing some problems. So let me to start with the first challenge or problem for us or difficulty. Data sharing among project partners is not always possible, even under signed NDAs. Why? Why? Because different legal advisors do different interpretation of the same law. I mean, we have a legal advisor in the project, but the hospitals and research centers which are the data holders that can share the data with other partners of the project have another interpretation, and we are finding important difficulties in order to share data between partners in order to carry out all the validation of the pilots. I mean, to train. I told you before, I will highlight later the idea of exploiting HPC and cloud architecture. Well, which partners in our case have this HPC infrastructure? The Barcelona Supercomputing Center with the Mare Nostrum computer, and the University of Torino, UNITO, that they have an infrastructure which is HPC for AI, which is a very important also. It's not the same computational power that Mare Nostrum has, but is an important HPC center. So the idea is that all the developments of academic partners and all the developments or industry partners in the project can test their developments, I mean, our models that we develop using the libraries, in these premises, I mean, in the premises of BSc and UNITO. And what we need in this case is to move data from some of the partners to the premises of BSc and UNITO in order to run the algorithms and test how our algorithms for training the neural network behave in huge HPC infrastructures. Okay, is what the purpose. Well, coming back to the different interpretation of the laws are the GDPR. These laws are the GDPR and other data protection regulations of European Union member states. Okay, so it's one of my worries about this. Okay, at this moment we are, how to say, we are passing some of the problems because we are reaching legal agreements between partners of different countries in order to share that, but not solve it 100% yet. Well, we have to highlight that health data is very sensitive data that might include patient informations. So involved people, not only doctors, also IT staff, researchers, people from industry, etc., must guarantee that no patient's information is disclosed. I will reuse this later, okay? And also we are interested in that validated or certified anonymization or pseudonymization and the identification techniques, but they are not easy to achieve. It's very difficult to develop a technique for anonymizing data and ensure that this data will not be possible to be used to reconstruct the identity of some of the patients, or at least one of the patients in the future, thanks to new algorithms that are not developed yet. So this is an arena which is so difficult, okay? But we have to have in mind that without risk, we cannot achieve, or we cannot have a scientific progress. So we have to agree to a balance, I mean, okay? So our proposal or suggestion or recommendation for this challenge, in order to address this challenge in the health sector, is that privacy and security by design must be taken into account, must be introduced, okay, at the beginning from scratch, in the definition of new standard protocols for collect and annotate data. I mean, we have to avoid that in an X-ray image or a CT image or a magnetic resonance image, they appear the name of the patient in the image. But it is so common, at least in all data, and also in structural reports, doctors write the name of the patient in some cases. So this is very difficult to de-anonymize. Well, in the case of images, we can do a crop, but not always the data appears in the same places. So this is not an easy task to be done automatically. So if good protocols and standard protocols are defined in order that all people collecting data in the health sector follow these protocols, then we can have in the future quality data properly anonymized, because the anonymizing effort is practically none. Okay. Well, in the meanwhile, I think legal, ethical, and technical committees must be created to issue data sharing authorizations in order to avoid the responsibility falling on individual doctors or medical teams. I think this is very important, because if some data or data coming corresponding to the same disease that is available in different hospitals, it will be nice, it will be very helpful for training models if all data corresponding to the same disease can be made together in order to build larger data sets, and which might take the decision of sharing this data. I think the responsibility should not be on doctors, should be on committees that are at the level of the state or even at the European Union. Another solution, which is very close related to multi-party computation that has been explained by Alex before, is federated and split learning under software restrictions, where only the trained algorithms can have access to data. Okay, the concept of multi-tenancy and so on is used in this context, but I think I have no time to dedicate to this aspect. So let me go to the next challenge, which is data is not curated enough.
Sorry, John,
well,
we are passing the allocated time.
Let me to summarize this one, okay? Well,
thank you.
We find that data is partially labeled or annotated. Not all data sets are available to work with them, are useful to train models. So this is an important issue we have to face. Why? Because non-standard protocols were followed, if they were followed some protocols to collect data sets for the same disease. This is what I told you before in the previous challenge. And relevant differences depending on the source origin are seen, or we can see relevant differences in data related to the same disease. Okay. And our proposal in this case is that standard ontologies must be a priority to be defined. Also, standard protocols to collect and store data for sharing fair data in Europe I think must be a priority. And in some cases, not in all the cases, because as I see in the case of the BodyPass project and the BigMedilytics project, the medical personnel is highly involved in the project, but is not in all the cases, and it is difficult to explain. But in one sentence, it is difficult for us to ask them to dedicate a little bit of their time to correctly label and annotate images, not taking existing data sets and doing the hard work of labeling all of these images of existing data. Just as new data is being collected, I mean, in the daily process of diagnosis, they can just make the little effort of correctly annotate and label this data. It is very helpful for us from the technical point of view. Well, that's all from my side, and thank you very much for your attention. Now I have to give you this change presenter to Alexandra. Okay?
Okay, thank you.
Okay, bye.
Okay, can you see my slide?
Yes.
Okay, thank you very much to all the presenters. And now it's time we have some time for questions and for discussion. And let's see the first question. Okay, I guess this question is for Javier. I see your project has an ethics board headed by a data protection officer. Is she a DPO of one of the beneficiaries? How do you manage data controlling roles at consortium level?
Okay, thank you very much for the question, Lorenzo. So regarding the DPO of our project, well, the DPO is in the call, is in the webinar. His name is Ricard. You can, if you are thinking in try to enroll a DPO in your project, which is highly recommended, you can enroll or involve him using two different approaches. One of them could be this organization could be a beneficiary itself, or you can involve the DPO as a third party. So, and we have done both approaches. Sometimes the DPO is one of our third parties, and sometimes is a beneficiary of the consortium itself. So it depends. Both options are good. My advice, I would think that it's better if the data protection officer is a beneficiary itself, especially in big projects. If the project is too small, maybe it's too much to allocate a beneficiary only for the DPO. But if the project is a big project, I recommend you to enroll or to involve a party that is focused only in privacy and security. I don't know if Ricard, you want to add something else?
I want to add something else, please. Let me give you an additional advice. It is really important to consider the task of the DPOs in front or related with the internal DPO of each organization. This is not only a work of the general DPO of the project. We need to be coordinated with the internal DPOs of each organizations if they exist. First advice. Second advice. If we are starting in that project, and usually we conceive the DPO as a consultant one, but we have to be accountable in terms of GDPR, as said Javier and John. To be accountable, this DPO needs a budget, need resources to training the teams, to travel to make reviews, to audit the processes, and so on. Then you have to conceive the tasks of the DPO of a working package itself.
Yeah, absolutely. And I can see another question, Alexandra, is how do we manage the data controlling roles at consortium level? So we definitely, this is a very good question. We include this information in the bilateral agreement that we sign among partners. So as I mentioned before, for example, at Incliva, we are collaborating with industry. So we have a bilateral agreement that explains very in detail the role of both partners, of both parties. So this is written down and is included in one annex of the agreement. And how we manage that? I mean, we find an agreement. We just discuss, having in mind our roles, our expertises, and so on. We come up with a solution, with a proposal.
Okay, and the next question is, how do you implement manual verification of uploaded data in the context of big data?
Okay, that would be for me as well, right?
Yes, I think so.
Okay. Thank you, Joao, for your question. This is in fact, it's a very good question. It's very easy. It's easier than it could be, because let me give you two examples. So, for example, we are working with images, with medical images. So what my colleague from the IT department audits is that the data that is taken out from our cluster is not images. So it is very easy, because the image is the weight of the image, the size normally is very high. So since the aim is try to extract some metadata, it's very easy to control if the data that the partner aimed to take out is not an image, a medical image. Okay, so this is the example regarding medical images. And when we are talking about data, what our aim is try to avoid the extraction of big amount of data. So this is related as well with the size of the file. So we are aware that this is not perfect, but this is a way to control that the data that the partners are extracting from Incliva are the proper ones, and we protect the identity of the patients. And on top of that, because we are aware that this is not perfect, we are aware of that, but on top of that, please bear in mind once again that we have signed a bilateral agreement that the partners that sign this agreement and use INCLIVA's cluster, in this agreement, they clearly express the intention of to not do any re-identification process, and also to, of course, extract only the data that they need. So we trust them. Of course, we trust the partners. That's why we work with them. But the technological, the technical process is quite easy, as you see. We are aware that we need to work on that, and in the future, next step for us is try to make this process automatically. Yeah, that's so far so good.
Okay, so we go to the next question. We have several questions, so we will try to be, please try to be quite concise with the answers. So the next question is, there is an, I guess this is for Alex Engers. There is an antagonism between anonymity and utility of data. Eventually, anonymization techniques may inject bias in the data set. Do you have some metrics to understand how good is your anonymized data with respect to your known problem? And more importantly, to understand their utility about unknown problems?
That's also a good question. So first of all, what we are using is multi-party computation. So that makes sure that actually enforces that the data that gets in cannot be used for any other purpose than where it is being used for. So it's cryptographically just impossible to use it for any other thing than for, in this case, the prediction model. We do have some statistics on to what extent the output of the model, how good that is, how good does it fit the data. We do not check for any bias in this process because in any case, if biased data get in, then you still can have a biased model. I would say that in case of healthcare data, that's no problem in many cases, because if, for example, there's a bias between men and women in heart failures, then it would actually be beneficial for both men and women to be able to predict more precise, more accurate. If you are a woman, then you can be treated as a woman. So yeah, so in that case, we do not check for any bias. We also do not introduce any bias within the anonymization process within multi-party computation. So yeah, I hope that answers your question.
Okay, and next one, I think this can be addressed to all of you. What about the usage of public cloud services that ensure GDPR compliance? Do you think health organizations are evolving to use storage and processing capabilities provided? They could serve as a way for sharing data more easily. Industry and also some health areas are moving from premises to the cloud. Have you observed this?
So many questions.
Oh, no, you have opinion. Surprisingly, the lawyer have an opinion.
Well, I can.
Okay, let me say only one thing. In my experience as a privacy expert, I'm seeing that industry, I'm talking about the big ones, are moving to ISO standards. Usually they are offering cloud standards based on ISO 27 and 18 standard with certification. And there are so many DPAs that are accepting that this is a trust processor to be contract. Then from the industry, there is a clear movement to provide cloud services for health research on that conditions. This is a real tendency of the market. I don't know if in terms of public authorities, health, public health services, and so on, they are working in each country to provide this big data lake in cloud, but in a public cloud in terms of property. I'm not sure. I know that we here in Spain, we are working in different regions to make it possible, but this is at the starting point of the process.
Let me to add something to this in order to answer this question. It's not related to law, it's related to information security. And my question is, if these providers, cloud providers, fulfill all the requirements regarding the law, all the laws possible, GDPR and local or EU member states, etc., is the data more secure in your local premises than in the cloud? Are you sure? Are you sure that your computing system or information system of all your hospital or research center is more secure against attacks, cyber attacks, than it is the service provided by the cloud provider? It's up to you.
Good point, John. I have to share with our audience that in Spain, public services have to work in a national standard. More or less is the same that ISO 27000 family. But of course, we are compulsory obliged by law to do that. I'm not sure if we are doing well. But of course, that is the reason that I'm specifically underlined the ISO 27018 standard.
I would like to ask something else, Alexandra, regarding the question that Monica pointed out. Do you think health organizations are evolving? So in our case, for example, in INCLIVA is a health research institute. We are very close to the hospital, and we are evolving. I mean, we have installed in our premises a cluster, computational cluster, as I presented before. And the process to access to our data is quite straightforward, it's quite easy. Fortunately, all the learning process that we have had with the European projects help us to have a process, a setup process. So now we are able to share, to grant access to our data in an easy way, let's say, or a more easy way than it was 2 years ago that we are starting from scratch. So in our case, we are already evolving, Monica. So we are happy to share data with any kind of partners, of course, with objective and having in mind that we need to pursue the benefit for the patients.
Okay. So just to clarify the first question we had about the DPO, so Lorenzo added, I understand you have a coordination. So, okay. I understand you have a coordination among DPOs and one DPO which coordinates with budget and resources in a project.
Yeah, sure. I mean, the DPO could we can allocate some budget.
Sorry, DPO for each partner.
I think Javier he's calling us that. Okay, how do you coordinate the works with local DPOs inside the project? I think we have to think global and act local. From my experience, when you are talking with an IP or PI with a principal investigator in the project or researcher and so on, requiring them information about data protection, usually they don't understand you. You need to have a really a strong contact with local DPO or security expert to obtain the real and useful information for the project. This is the reason that you have to coordinate with local DPOs, security experts, and so on as a part of your task. Because if not, you are talking with people who don't understand you in any way.
Okay. And the last question is the following. Are in your projects any plan of sharing data with research community in an open way similar of USA initiatives?
Should let me answer something that is aligned with my last answer. We are happy to share, to grant access to our data, but what we don't have in mind is to put all our database in an open platform so anybody can access to it. So to access to our data, you need to follow a process that we have set. So that means bilateral agreement and objective of the project and so on and so on. So it's possible, in our case, it's possible to grant access to data, but we are not thinking in putting all our data in a big cloud, open big cloud.
Alexandra, in our project, it is not the special case of any of the use cases, but one of the outcomes of the project is a definition of a data lake, of how a data lake should be structured, and also how can be anonymized in particular data images, so images from the health sector or images in general, in order that this could pave the way for providing open data in the future. But as I said before, not specific use cases of the current project, but we are working, some of the partners are working in this line, not me. I am not data provider.
I would like to add
that, sorry, in the long term, I am convinced that we will have this kind of data lake in Spain or in Europe with all this data. But I think that this is a long-term action. In a short term, I think that we cannot work like, for example, USA or China.
In the BodyPass project, the approach is that each data is the property of each partner, and what we have is a architecture we connect to blockchain. Then it's possible to establish some kind of smart contracts. Then the approach is, I think, we are using blockchain. Maybe it's possible to automatize all the systems to agree in order to exchange data. But I have to say also that my experience is that this type of approach is easy with in the industry, but very difficult with the healthcare sector, because I have to say that especially the public healthcare sector is very cautious in order to before to establish any type of agreement to exchange data.
Okay, so let's see if there is any other question. I think no. So we have run over the time. So we can conclude here. Thank you very much for the presentations, for the questions, and for your attention. And well, you will receive an email. I think you will receive information on where you can find the presentation, the recording, and the materials. Thank you very much again for attending this webinar.
Thank you to everybody. Bye-bye. I'm closing the webinar now. Thanks to all the presenters.
Bye.
Bye.